Hello, and welcome to the fourth in the series on integrating with Excel. And in this tutorial, we're going to talk about how to optimize shapes. So first off, we're going to talk about what is the Newton method, then where to find this optimize.xlsm Excel document that we're going to talk about. I'm going to do a walkthrough of the code, and finally just watch the execution of it. So Wikipedia has a real nice little write-up on Newton's method, or Newton-Raphson method. And what it is a way to find the roots or zeros of a real valued function. So briefly, you pick a location, some value of x, and then you compute the ratio of the value of the function that you want to zero at that location and its derivative at that location. Subtracting that ratio, you get a new value of x. And you keep going until your function is very close to zero. And it's got a beautiful little chart down here. Watch this. So there's your new location. Compute the value of the function and the tangent. Get a new location, and you keep on going until you get to something very close to zero. That's a nice graph. So to find the optimization document, we go to the installation directory, and the default is Program Files, Structures Office Documents folder, and open it up. So here's our Excel document, and let's just dive right into the code. So I pick View Code, and this is what's going to execute when that Optimize Shape button is clicked. This is the same code as always to search the spreadsheet for the Structures Office object, then calls the Newton-Raphson routine given the initial length value and then the target value that we're looking for. When it's done, it writes out the section properties here. As if we look at the Newton-Raphson method, here it is, and there's a note that says you don't need to modify this code. So you just define a new function. You pass in a parameter and a target value. What you need to modify is this function that was called f here. So if we go up, we'll find this value, this function f, and it has the parameters of the Structures Office object, and then our parameter is a length. So what we're doing is we're creating an I-beam, which is defined as a function of the flange lengths, or the widths and thicknesses of the flanges are defined as the function of that length, and then computes the section properties, and then the value that we're looking for is the principal min of the radius of gyration for the geometric section properties. So of course this part of the code you would define based on whatever shape it is you want to create. It's just got to be a function of a single value. So let's walk through the Newton-Raphson portion a little bit. So we pass in this length. To start out with, it just takes in, it sets this x last value as some offset from that length, zeroes out C6, which is this current value. It then computes the function at this offset value, stores it in f last, Sets our f new equal to f last. Then it goes into this loop, looking to see if our value of f new is close to the target value within this tolerance. And that is defined down here as a relative error. dx is the delta in the length values. F new is computed as based on this most recent value of x new. It does a approximation for a derivative here. So it takes the delta in the value of f, the radius of gyration, versus the change in the delta in the lengths, and then does a little check here to see, well, if that's 0, that's a problem, and it gets out. Otherwise, just as we saw in that introduction to the Newton method, it computes an x new based on the delta from f new versus the target, because we want to zero that thing, and this is our approximation for the derivative. And then when it takes that value that we just computed and stores it up here so you can watch it run, see, as it's iterating. So let's just kick that thing off and watch it go. So my target value of 6.5, the initial length is going to be 10. I'll get out of design mode, click optimize, and you see the shape being built, and you see our current value changing. Now let's say we want to go to some other value. Let's say our target is 12, and optimize the shape. Here's the first approximation, and there it is. And if we go down here, we better see that value. So to summarize, to change that document that we just talked about, the Excel document, to something you want to optimize on, you're going to have to define just that f function. You have to create a new single-valued function. And it's got to be parameterized in some way, and a value that you're looking for, the section property that you're looking for. So that's it for this optimization tutorial. Thanks for listening.